Before we discuss chemicals and hazardous materials, it's important to understand some basic terms. You may or may not be familiar with these terms, but if you handle, use, store, or dispose of chemicals and hazardous materials, it's very important to understand the terminology. ppm is a term that is quite familiar to anyone working with chemicals and toxic materials. It means parts per million. The health effects of any toxic substance are related to the amount of exposure, also known as the dose. The greater the dose, the more severe the effects. Some chemicals can cause toxicity at very low doses, so it is important to be able to understand how these very small amounts are described. It is especially important to understand how low doses compare to one another and what they represent when compared to amounts of more familiar substances. Parts per million, ppm, parts per billion, ppb, and parts per trillion, ppt, are the most commonly used terms to describe very small amounts of contaminants in our environment. They are measures of concentration, the amount of one material in a larger amount of another material. An example might help illustrate the part per million, part per billion, and part per trillion equations. Let's use 1 part per billion. To give you an idea of how little this would be, a pinch of salt in 10 tons of potato chips is also 1 part salt per billion parts chips. Similarly, 1 part per billion of an impurity in water represents a tiny fraction of the total amount of water. 1 part per billion is the equivalent of 1 drop of impurity in 500 barrels of water. Permissible exposure limit, or PEL. This is an exposure limit that is published and enforced by OSHA as a legal standard. PEL may be either a time-weighted average TWA exposure limit within an 8-hour period of time, or a 15-minute short-term exposure limit STEL, or a ceiling C. Threshold limit value, TLV. Threshold limit value is an airborne concentration of substances that represent conditions under which it is believed that nearly all workers may be exposed day after day with no adverse effect. TLVs are advisory exposure guidelines, not legal standards. TLVs are based on evidence from industrial experience, animal studies, or human studies when they exist. There are 3 different types of TLVs: time-weighted average, TLV-TWA, short-term exposure limit, TLV-STEL, and ceiling, TLV-C. Time-weighted average, TWA. The average time over a given work period, such as an 8-hour workday, of a person's exposure to a chemical or an agent. The average is determined by sampling for the contaminant throughout the time period, represented as TLV-TWA. IDLH, immediately dangerous to life and health, which represents the maximum concentration of a chemical in the air to which a healthy adult worker could be exposed for 30 minutes without suffering permanent or escape-impairing health effects. Okay, we know about PEL, or permissible exposure limit, threshold limit value, time-weighted average, STEL, or short-term exposure limit, and TLVC, or ceiling, and IDLH. These terms are used to determine your exposure to concentrations of chemicals and what protection you need to reduce exposure to potentially harmful chemicals. Chemicals are often flammable, combustible, toxic, corrosive, and other hazards, so you have to know and learn this information as part of your job responsibilities. Let's examine the chemical benzene. In this program, we'll discuss some of the hazards of the chemical, how it's identified, and how to determine if you're being exposed. Basic workplace exposure limits, ways of reducing your exposure, medical information, and general safe work practices. We will also review information relating to protection from benzene exposure, such as personal protective equipment and respiratory protection. To get started, let's take a look at some of the hazards of this chemical. Benzene can affect you when breathed in and by passing through your skin. Benzene is a carcinogen, which means it can cause cancer, so handle with extreme caution. It can irritate the eyes and skin with drying and scaling of the skin. Benzene can irritate the nose and throat and can cause symptoms of dizziness, lightheadedness, headache, and vomiting. High exposure may result in convulsions and coma or sudden death from irregular heartbeat. This tells you that benzene is a dangerous chemical if not handled properly. Prolonged exposure can cause damage to the blood. It is a flammable liquid and a fire hazard. You will receive additional training to help determine exposures, but your company provides routine evaluations, including collection of air samples. If you believe you are experiencing any work-related health problems, notify your supervisor, so a doctor specifically trained in recognizing occupational diseases can make that determination. The information provided here is basic, and your company may have more stringent requirements for exposure limits. The legal airborne PEL, or permissible exposure limit, is 1 part per million, averaged over an 8-hour period work shift. 5 parts per million should not be exceeded in any 15-minute period of time. The range of accepted odor threshold values is 34 to 119 parts per million. In other words, it takes about 34 to 119 ppm for you to detect this chemical, which is 33 to 118 times the permissible exposure limit. Caution should be used in relying on odor alone as a warning of potentially hazardous exposure. Some chemicals have characteristics that can be perceived by workers and can serve as a warning of the chemical's presence. The lowest concentration at which the odor of a chemical can be detected is called the odor threshold. Some substances, such as asbestos, have no odor and therefore provide no warning of their presence. In many cases, the concentration of a chemical that can be detected by odor and the concentration that is capable of causing adverse effects are similar. Some chemicals and gases, specifically propane, has no odor, so the propane manufacturer adds an odor to the gas, so it can be smelled, indicating the gas is in the air. Benzene is a carcinogen, so there may be no safe level of exposure. All contact with the chemical should be reduced to the lowest possible level. The workplace exposure limits of 1 part per million is for air levels only. When skin contact also occurs, you may be overexposed even though the air levels are less than 1 part per million time-weighted average. The best method of reducing exposure is through engineering controls. Enclose operations and use local exhaust ventilation at the site of chemical release. If proper engineering controls cannot be effected, respirators should be worn. A regulated marked area should be established where benzene is handled, used, or stored as required by federal or state regulations. Post hazard and warning information in the work area. Wear protective work clothing. Wash thoroughly immediately after exposure to benzene, before you eat or drink anything, and at the end of your work shift. Where possible, automatically pump liquid benzene from drums or other storage containers to process containers. Contaminated work clothes should be laundered by individuals who have been informed of the hazards of exposure to benzene. Eye wash fountains should be provided in the immediate work area for emergency use. If there is the possibility of skin exposure, emergency shower facilities should be provided. On skin contact with benzene, immediately wash or shower to remove the chemical. At the end of your work shift, wash any areas of the body that may have contacted benzene, whether or not known skin contact has occurred. Do not eat, smoke, or drink where benzene is handled, processed, or stored, since the chemical can be swallowed. Wash hands carefully before eating or smoking. Many scientists believe there is no safe level of exposure to a carcinogen. It should also be treated as potentially harmful to reproductive organs. Repeated exposure can damage the blood-forming organs, causing a condition called aplastic anemia. This may cause death. Exposure to benzene can cause drying and scaling of the skin. Before beginning employment and at regular times after that, a complete blood count should be taken. Any evaluation should include a careful history of past and present symptoms with an exam. Medical tests that look for damage already done are not a substitute for controlling exposures. You should request a copy of any medical testing provided. The information provided in this program is only a guide and may not apply to every situation. Workplace controls are better than personal protective equipment. However, for some jobs, personal protective equipment may be appropriate. Wear solvent-resistant gloves and clothing. All protective clothing should be clean, available each day, and put on before work. Wear splash-proof chemical goggles and face shield when working with liquid, unless full face piece respirator protection is worn. Improper use of respirators is dangerous. Such equipment should only be used if the employer has a written program that takes into account workplace conditions, requirements for worker training, fit testing, selection of respiratory equipment, and medical exams. Where the potential exists for exposure over 0.1 part per million, an approved supplied air respirator or approved self-contained breathing apparatus with full face piece. Exposure to 3,000 parts per million is IDLH or immediately dangerous to life and health. All respirator protective equipment must meet federal and state requirements. Prior to working with benzene, you should be trained on its proper handling and storage. Store benzene in tightly closed containers in a cool, well-ventilated area away from heat. Sources of ignition, such as smoking and open flames, are prohibited where benzene is handled, used, or stored. Metal containers involving the transfer of benzene should be grounded and bonded. Drums must be equipped with self-closing valves, pressure vacuum bungs, and flame arresters. Wherever benzene is used, handled, manufactured, or stored, use explosion-proof electrical equipment and fittings. Always follow your company's emergency action procedures. The following information is only a guideline. If benzene is spilled or leaked, take the following steps. Restrict persons not wearing protective equipment from area of spill or leak until cleanup is complete. Remove all ignition sources. Cover liquids with activated carbon absorbent or other approved material and deposit in sealed containers. Ventilate area of spill or leak after cleanup is complete. Keep benzene out of a confined space, such as a sewer, due to the possibility of an explosion. Benzene-contaminated material may be classified as hazardous waste and may require proper disposal according to EPA and other federal or state regulations. If benzene comes in contact with the eyes, immediately flush with large amounts of water for at least 15 minutes, occasionally lifting upper and lower eyelids to get water into the eye. If there is skin contact, quickly remove contaminated clothing. Immediately wash area with large amounts of soap and water. Seek medical attention. If a person has breathed benzene, remove the person from exposure. Begin rescue breathing if breathing has stopped, and CPR if heart action has stopped. You have the responsibility to work and act safely. And part of that responsibility is protecting yourself and others from the potential hazards of this chemical. Know, understand, and follow your company's policies and procedures relating to benzene. If you have any questions, be sure and ask your supervisor. Your health and safety are just too important. Thank you.